Alright, hi guys. In this video we're going to learn how to find arc length and sector area. We're going to be using both degrees and radians. So the first thing we need to talk about is what is the circumference of a circle measuring. So the circumference of the circle is the same as the perimeter. So it would be like if I were standing right here on this very large circle and I walked all the way around the outside and back to the starting point, like how far did I go? So that's what diameter, or the circumference, sorry, is measuring. So we're going to be using the circumference formula for part of this, which is the circumference is equal to 2 times pi times the radius, or I could think of it as pi times the diameter. And that's just because 2 times the radius is the same as the diameter. So 2 times the radius times pi, or pi times diameter, that's what gives us circumference. The other thing we could look at is the area of the circle. So the area is measured in square units. It's how many square units would fit inside the circle. So the formula for area is A equals pi r squared. So square the radius, times it by pi, and that will give you the square units that will fit inside the circle. So what an arc is it's part of the circumference, right? So instead of measuring all the way around the entire outside, we just want to know what the length of this little piece of the circumference is. So we're still going to have to use circumference formula, but then we're going to have to multiply it by the fraction of the circle that we're looking at. Okay. So for example, if this angle in here, so right now this is theta, it's like a little variable that we use for a missing angle. If this were, say, 25 degrees, then I could find the fraction of the circle that this arc is just by thinking about how many degrees an entire rotation is. So in a complete rotation of a circle, if I went all the way around, that would be 360 degrees. But this angle has only rotated 25 of those degrees. So this would be 25 over 360. That's the part of the circle that we're looking at. And then I would need to multiply that by the circumference, which is just 2 times pi times the radius. So let's say our radius is 8 inches. So this part right here is the circumference. And since that's the circumference, or the distance around the entire outside, we have to multiply it by the fraction of the circle that we're looking at, which in this case would be 25 out of 360 degrees. So if you just put all of this in your calculator, that's going to tell us how long this arc is. So this gives us 3.49, and since our radius was in inches, our arc length will also be in inches. So it would be 3.49 inches. Okay, so let's try a couple more examples. So if my central angle here is 72 degrees, that's going to be 72 out of a complete rotation, 72 out of 360. So that's how we get the fraction of the circle that we're looking at. We're trying to find this length between A and C. And then we're just going to multiply this by circumference formula. And remember, circumference is 2 times pi times r. So in this case, 2 times pi times 2, because our radius is 2 centimeters. So again, just put this all in your calculator. 72 divided by 360 times 2 times pi times 2 gives me 2.5. Let's keep 2 decimals here. So 2.51 centimeters. Okay, let's try one more of those. So here we have our central angle is 155 out of 360. That's going to be the fraction of the circle that we're looking at. So we're going to times this by the circumference of the circle, which is 2 times pi. Now notice here it says d equals 8. So that would be the diameter all the way across. So to get the radius, we would need to divide that in half. So our radius is 4 millimeters. So times by 4. And then just plug that into your calculator. 155 over 360 times 2 times pi times 4, 10.82. So 10.82 millimeters. Okay, so we're just finding the circumference, but then just multiplying it by whatever the fraction of the circle we have, which we always just take that central angle and divide by 360 in order to do that. Okay, so what happens when our central angle is given in radians instead of degrees? So this angle right here is pi over 2 radians, and our radius is 2 centimeters. Well, in a circle, a complete rotation in degrees was 360, right? But in radians, a complete rotation is 2 pi. So here, on the bottom of our fraction, instead of dividing by 360, we divide our angle by 2 pi, because 2 pi is a complete rotation in radians. So I'm going to have pi over 2 divided by 2 pi times the circumference. Remember, circumference is 2 times pi times the radius. And our radius is 2, so that's another 2. But notice here that whenever I use circumference formula, I'm going to have a 2 pi. And whenever I'm in radians, I'm going to divide by 2 pi. So I have a 2 pi on the top and a 2 pi on the bottom. So those are going to cancel out when I'm in radians every single time. So I'm just left with that central angle, pi over 2, times the radius, which is 2. So that would just be pi times 2 is 2 pi. 2 times 1 is 2. So this would just be pi, or about 3.14 centimeters. Okay, so what we need to think about here is that every single time we are using the circumference formula to find arc length with our central angle in radians, we're always going to end up dividing by 2 pi, so those will cancel out every time. So in order to find arc length when our angle is given in radians, and I can tell it's in radians because there's no little degrees up front or out to the side, and there's a pi in the angle, which is a dead giveaway that it's radians. So our arc length is going to be calculated just by taking the central angle times the radius. Okay, again, that's only when it's in radians. If it's in degrees, just divide by 360 and times by the circumference. But if it's in radians, we can just take those two numbers, pi over 2 and 2, and multiply them together, and that's going to give us the arc length. Okay, so let's try one more. So I've got 2 pi over 3 as my central angle. I've got 8 millimeters, and I'm going to go ahead and just take the central angle, which equals 2 pi over 3, and I'm going to times it by the radius, which equals, remember the radius is half of the diameter, which equals 4. So it's just 4 times 2 pi over 3. So you can just plug that into your calculator, 4 times 2 pi over 3. And that gives me 8.38, if I round it up. 8.38 millimeters. Okay. So let's go ahead and now look at something called sector area. So a sector of a circle is just basically like a piece of pie or a piece of pizza that comes out of the circle. This is the center of the circle here, and so we just take, it's similar to arc length, but now we're trying to find the area of this section, not just the length of that arc. So in order to find the area of this, I can use area formula to find the area of the entire circle. So pi times radius squared. But I'm going to need to, again, find the fraction of the circle that I'm talking about. So this central angle in here, which is theta in this case, so it's not an actual number, but it's just standing, it's a variable standing in for the number, over a complete rotation in degrees, because if our angle is given in degrees, times the pi r squared. And that's going to give us the sector area. Okay, so let's go ahead and do a couple examples of this. So if my central angle is 65 degrees, I know the fraction of the circle I'm looking at is 65 out of 360. And then I would just want to find the area of the circle. The area of the circle would be pi times radius squared. My radius is 3 centimeters, so pi times 3 squared. Okay, and again, just plug it into your calculator, 65 divided by 360 times pi, and then times 3 squared, which is 9. That's going to give me 5.1, and I'm going to round it up, 5.11 centimeters squared. Okay, remember our area is always given in units squared. So 5.11 centimeters squared. Okay, let's do one more example of this. Okay, so this time our central angle is 130 degrees. So I know the fraction of the circle I'm looking at is 130 over 360. And then the diameter is 5 inches, which makes my radius 2.5 inches. So I'm going to multiply this by 2.5 squared times pi. I did those backwards. Pi r squared and r squared pi is the same now, so it's okay. So if I multiply this all out, I've got 130 over 360 times 2.5 squared times pi. And that's going to give me 7.09 inches squared. Okay? So now let's look what happens when, actually we're going to skip that one. Let's look what happens when my angle is in radians. So I know I'm going to take my central angle and I'm going to divide it by, because I'm in radians, I'm going to divide it by 2 pi. So this is sector area for radians, right? We're going to make a little formula over here again. And I'm going to times it by pi r squared because that's the area formula. So the area of the entire circle is pi r squared. My central angle divided by 2 pi because a complete rotation in radians is 2 pi. So instead of dividing by 360 here, I will divide by 2 pi. This pi and this pi will cancel out every time. So I'm just left with theta, that central angle, whatever it is, in this case it's pi over 2, times the radius squared divided by 2. So only when it's in radians, I can just take the central angle and times it by the radius squared and divide the whole thing by 2. So here my central angle is pi over 2, so I'm going to take pi over 2. I'm going to times it by the radius squared, so 2 squared, divide the whole thing by 2. Okay, so in your calculator, just what is pi divided by 2 times 2 squared, and then divide the whole thing by 2. And it gives me 3.14. Let's see, it would be centimeters squared. Okay. Last example, my central angle is in radians. I can tell it's in radians because there's no degrees and it's got a pi in there. 2 pi over 3. So I can just take my 2 pi over 3 and that's the central angle, times it by the radius squared. So my radius here again is 4 millimeters because the diameter is 8. And then divide the whole thing by 2. And when I do that, I get 0.065. Let's see, is that right? 2 pi over 3 times, oops, nope, I did that wrong. So 2 pi over 3 times 16 divided by 2. I accidentally divided by 16 as well. So this would be 16.76 millimeters squared. Okay, so good luck. Give these a try, and I will, if you have any questions, just email me. Thank you, bye.